Okay, we're going to start looking at some of the exponent laws. So let's remember first off even just what an exponent is. So if I have, let's say 2 over 5, all to the exponent 3, this whole thing is called a power. The part inside the brackets is called my base. And because it's all in brackets, in this situation, my whole base is 2 over 5. And then the little number up top is called my exponent. And let's remember even just what that means. So that would mean that I would take my whole base. So that's the same thing as writing 2 over 3 times 2 over 3 times 2 over 3. So that exponent tells me how many times I'm going to multiply my base by itself. Okay, and then let's think about our fractions. How do we do this? Well, we multiply your numerators, 2 times 2 times 2, which is 8, all divided by 3 times 3 times 3, which is 27. So what I've attached for you is also, I've got a nice little table here. So you can see the bases are on the one side, exponents are across the top. So you can always refer back to this. So if, say, you need to figure out what 2 to the exponent 7 is, you can read, there's my 2, read across, find the 7, and you can see there that 2 to the exponent 7 is 128. So it's a great table that we can refer to while we do this unit. Okay? Let's also make sure we remember about brackets. So brackets, beware. Very important. If the number is inside the bracket, so if I have negative 3 to the exponent 2, then I'm squaring all of it. So that means I've got negative 3 times negative 3. So in this case, I would end up with a positive 9. But if I don't have those brackets, if I just have minus 3 to the exponent 2, well, that exponent is only hitting the 3. So I would have a negative out front, but then it becomes 3 times 3. So in this scenario, I have a negative answer. 3 times 3 is 9. Okay, so you have to watch where that exponent is actually being applied. Okay, let's start looking at rule 1. So rule 1 says to multiply powers with the same base. We're going to have to do something with the exponent. So let's try an example and let's see what we see. Let's try doing x squared times x cubed. So let's write this out long just to see, what's going on. So x squared means I've got x times x. And x cubed says I've got x times x times x. So if I'm going to do x squared times x cubed, how many x's do I have in total? I have 1, 2, 3, 4, 5 x's. So my answer in this scenario is going to be x to the 5. Well, how do I turn 2 and 3 into 5? Well, I add them. I added them all up. I had 2 plus 3 gave me 5. So I'm going to add the exponents. So that gives us our rule. So our rule will be b to the n times b to the m is n plus m. And that's a great rule. So let's try another one. Okay, so let's put rule 1 into action. I've got 3 different examples here, and I want to write my answers as a single power. So I don't even care what the actual final answer is. I just want to write this as a base with one exponent. So as long as my bases are the same, to do this, we're going to add our exponent. So I get 4 as my base. Exponents become 3 plus 7. And what does 3 plus 7 equal? Well, I have 4 to the exponent 10. Okay, sure. Let's do the next one. Here I have the same base, which is 6. I have an exponent 8 and 3, so let's add them up. 8 plus 3, so my final answer is going to be 6 to the 11. Last one, now I've got an x to the 5 times x to the 7 times x to the 3. Same rule applies, so I keep my same base, and then I add my exponents. 5 plus 7 plus 3. So if I do 5 plus 7 plus 3, I end up with x to the 15. Okay, let's talk about rule 2. This time we're going to divide powers with the same base. So to figure out what we're going to do with these exponents, I have a nice little example here. And instead of leaving it in this format, I'm actually going to write it as a fraction. Okay? So x to the 7 is going to go on top, right? This is all divide means. X to the 7 on top, x to the 4 on the bottom. Okay? And then just like before, I'm going to expand it out. So I'm going to write 7x's on top. 1, 2, 3, 4, 5, 6, 7. All divided by. On the bottom, I'm going to write 4 x's. So I've got 1, 2, 3, 4 x's on the bottom. And what we know about dividing, when you take something and you divide it by itself, it cancels out. Okay. So this one cancels with that one. Oops, you can't see. Try that again. This one cancels with that one. This one cancels with that one. This one cancels with that one. And this one cancels with that one. And I'm all out of ones to cancel. So how many do I have left? I have 1, 2, 3 left. So I now have 3 x's left. So that means that I have x to the 3. Well, then the question is, well, what happened to these guys? Well, I ended up subtracting them off. So when we're dividing, we're really going to subtract our exponents. Okay. So there's our rule. To divide powers with the same base, you actually subtract the exponents because that's our canceling. So the subtracting is what takes care of the fact that we've canceled. So I could have written x to the 7 divided by x to the 4 equals x to the 7 minus 4, which would have given me x to the 3. Nice. All right, let's use our rule. I've got a couple of examples here. Again, we just want to write it as a single power. We're not actually going to evaluate it. We just want to use the rule, okay? So since I'm dividing, I know that means I'm going to subtract my exponents. So keep the same base. And I want to do 8 minus 2. Final answer will be 5 to the exponent 6. Okay. I've also got one written as a fraction. Fraction means the same thing as divide. So I keep my base. Exponents are going to subtract. So I get 9 minus 3 equals 9 minus 3 is 6. So my final answer will be 10 to the exponent 6. Example C, well, I've got x's and I've got y's. Well, that's okay. You just apply the rule to the x's and then you apply the rule to the y's. So we're going to have x to the exponent 11 minus 9. 11 minus 9 times y to the exponent 3 minus 2. So my final answer here is going to be x. 11 minus 9 is 2. Y, 3 minus 2 is 1. So you can leave it like this because that means 1, or I can give it the exponent 1. It's totally up to you. Okay, so now we want to look at the rule 3, which is a power of a power. So to simplify a power of a power, what does that even mean? Okay, so let's say I have x to the 4, which is a power. And then outside my brackets, I'm going to give it another exponent. So now I have a power to a power. Okay. And to figure out how to do this, again, I'm going to expand things out. So x to the 4th is my new base, and I want to cube it. So I want it 3 times. So I've got x to the 4 times x to the 4 times x to the 4. Oh, we already have a rule for how to handle multiplying. When I'm multiplying, remember that means we add our exponents. All right, so I've got x, 4 plus 4 plus 4. Well, isn't that the same thing as saying I've got 3 times 4? Oh, okay. So I had, my exponent is now 3 times 4. Well, what does 3 times 4 equal? 12. So that's how we do it. When I've got a base inside that has an exponent, and then another exponent on the outside, To get my simplified answer, I just need to multiply my exponents. Okay, let's try a few examples. All right, let's use our rule. So first example, I've got 5 to the exponent 2, all to the exponent 4. And again, all I'm doing is just writing as a single power. I don't have to evaluate yet. So I keep my base, I take my exponents, and I multiply them. And 2 times 4 is 8. So my answer is 5 to the exponent 8. Let's try that with the x. So same thing, keep my base, multiply my exponents, and you get x to the exponent 70. Last one, keep my base, multiply my exponents, and you get 8 to the 33. Okay, so now we're going to talk about rule 4, which is really just combining the other ones. It's a power of a product or a quotient. So in this case, we have to make sure that we apply the exponent. And the exponent's going to be on the outside of the brackets. Exponent on the outside to each number and variable inside. To each number or variable on the inside. So this is now where things start to get a little bit more complicated. So for example, if I do x, y, all to the exponent 3, well, this rule is telling me that that exponent is going to hit the x and it's going to hit the y. So this is going to equal x cubed, y cubed. Okay. If I had an example that's maybe got a number in there, so let's say that's 5, and let's say I have 5x squared. And we're going to put that all to the exponent, I don't know, let's go with 4 this time. So that 4 has to come in and it has to hit the 5. So we've now got 5 to the exponent 4. And it has to come in and it has to hit that x squared. So now I have to use my other rule where I say, well, when it's outside brackets, I now have the exponent 2 times 4. So that gives me a final answer of 5 to the 4, x to the 2 times 4, which is 8. Okay. Let's maybe try one with brackets. So these ones were products. Quotients, well, that just means you're dividing. And let's write it as a fraction. So let's say I've got x squared y cubed divided by, I don't know, 8. And let's put that all to the exponent 4. Okay, so that exponent has to come in and it has to hit everybody. So it's going to come in and it's going to do the rule on my x squared. So that means I have x to the exponent 2 times 4 because it's coming in from outside. I'm going to have it on my y. So I now have a y to the exponent 3 times 4. And then that's all going to be divided by, that exponent has to apply to the 8 as well. So I'm going to have an 8 to the exponent 4. Finish it off. I'm going to have x to the 8, because that's what 2 times 4 is. I'm going to have a y to the 12, because that's what 3 times 4 is, all divided by 8 to the 4. And this time I am probably going to want to evaluate it, because it looks a little silly not evaluated. So let's remember our little table that I had over here. So if I want to figure out 8 to the exponent 4, I go to my base 8, exponent 4, 4096 is my answer. 4096. 4096. Because that's what 8 to the 4 is. Okay, let's combine some of our rules and a few more complicated examples. Here I have, everything has the base 3. I've got a 3 to the 4 times 3 to the 8, all divided by 3 to the 7. Just work left to right, apply our rules. So we know when we're multiplying, we need to add our exponents. So I get 3 to the 4 plus 8. Okay, and this 3 to the 7 can tag along. 4 plus 8 gives me 12, so I get 3 to the exponent 12 divided by 3 to the exponent 7. And now I know my rule for dividing is subtracting. So I get 3 to the 12 minus 7 is 3 to the 5. Okay, and then let's bring up our little wee table here. 3 to the exponent 5 is read across, 2, 4, 3. So final answer, 2, 4, 3. Now when I'm doing these questions, I often ask you to show me using the rules. So this would be the part where you are using the rules. This is writing it as a single power. And then the very final step, when you give me an actual number, this is evaluated. Okay. So it depends on what the question asks, depends on what you want to do. I will almost always ask you to use the rules right as a single power, and sometimes I ask you to evaluate. Okay? Okay, we're almost done here. Let's do this lovely example. So let's deal with our numerator first. We're going to simplify it. Because I'm multiplying, I'm going to add my exponents. And when an exponent is not written, it's understood to be a 1. Okay? So in my new numerator, I've got 6 to the exponent 1 plus 7 all over. And we can simplify our denominator at the same time. So here I've got a power of a power. So we're going to multiply those exponents. So you end up with 6 to the exponent 3 times 2. Let's simplify that up a little bit. 6 to the exponent 1 plus 7, so that becomes 6 to the 8 in my numerator. And my denominator becomes 3 times 2, so 6 to the exponent 6. Now I can see that I am dividing, so that means I need to subtract my exponent. 8 minus 6 gives me the value of 6 squared. So I've now written it as a single power, and if I wanted to evaluate it, well, 6 times 6 is 36. All right, let's squeeze one last example in here. Here I've got a squared, squared, squared. Oh my goodness, that's okay. It's just a power to a power to a power, so we just keep using our same rules over and over again. So we know a squared squared is the same thing as a to the 2 times 2, all squared. So I'm just going to work from the inside out. So that means I've got a to the 4, all to the exponent 2. Use my rule again, and you've got a to the 4 times 2. Well, I guess I didn't need brackets anymore. Gives me a final answer of a to the 8. So all I did this case, when I've got lots of different brackets happening, is I just worked from my inside out. So I put those guys together in my first rule, and then I worried about the last one last.